Hello to all my young friends who are studying in intermediate and they are watching this video. Welcome to Calculus Made Easy series. Today we are going to start a new topic, which is how to find the derivative of inverse trigonometric function. I hope that you must be familiar with inverse trigonometric functions because they are taught in trigonometry. But many people find it a bit difficult or complex, not easy to understand. So, I'll take a couple of minutes to explain as to what is inverse function so that you don't face any confusions in this topic because we'll be using certain properties of inverse uh, trigonometric functions, especially when we find the derivative and when we put the conditions there. So, I'll be explaining that briefly. So the people who are not able to understand this topic, inverse functions, so I'll be covering that topic in detail when I post my videos on trigonometry, which will I'll be doing it shortly. So please do see that if you have problem with that. But whatever I'm teaching you today, that is sufficient for this topic for understanding the derivative of inverse functions. For the people who know it, it will be a refresh of their you know knowledge on inverse trigonometric functions. Now let's start our topic today, the derivative of inverse trigonometric function. So what is an inverse function? An inverse function or an anti-function, we also call it an anti-function of a function f. Suppose you have an inverse function of f. It undoes the action performed by the function f. So whatever action has been performed by f, the inverse is going to reverse it or it undoes that, right? This is the basic uh, concept of inverse function. For example, if we have function in f in the shape of a box, we put certain input here and we get an output. Say, if you put an input fx, you will get an output of fx. You must have, studied function we express it at fx is equal to x square, for example, plus 2. Now, if you put the value of x as 3, now f3 is equal to 3 square plus 2 is equal to 9 plus 2, which is going to be 11. So, this is your output and this is your input. So, here x is the output and fx is the x is the input, sorry, and fx is the output. Now, if we have a anti-function for this function or inverse function, then there, if you put this output, again it is going to give you the input of the function with f. So that means this is the input and this is the output for function f. Same output you put in anti-function as input and you get the output as x. Okay. So I think this must be clear to you. So in simple words, if any function takes x to fx, then inverse will take fx again back to x. Now inverse is also denoted by f, but here we should not be confused with this as a power. It is not equal to 1 upon f. This is not an exponent. This is just a symbol. This is a symbol and not a power. So if the function takes x and makes it fx, then the inverse function, which is f inverse, will again take it back to x. That is the basic concept which we have shortly discussed. Now, what is domain and range in these cases? Now, x is taken to fx by this function f, and fx is again taken back to x. So for function f, this is the you know input value which you call domain, and this is the output values which we call range. Now for this function inverse, this range becomes the domain here because it is the input, and finally you get the domain here. So that is the output here because it's going to take you back. Let me explain you with this example. For example, for a function fx, if you have domain as abc and range as efg, that means this function f takes this whole set to this. This is the domain and this is the range. For example, it takes a to e, b to f, or c to g, or anyway, it can be a to f or a to g, anything like that. Now, for inverse function, inverse will take it again back, take it efg to abc. That means for inverse, this will be the domain and this is going to be the range. So domain is efg and range is abc. I hope that is clear. And one more very interesting thing, inverse is a reflection of f. Reflection of f, it's a mirror image of f about the line y is equal to x. Please note it. It's a reflection or mirror image about the line y is equal to x. That means if you keep a mirror at the line y is equal to x, one side you will find f, so other side you will find f inverse as a reflection of f. Or if you keep f inverse on one side, you will find f on other side as a reflection of f inverse. So let us just see that. For example, if you have function f, the input value is 5 and the output is 2. This is your input and this is your output. Now for inverse, we put this output and we again it takes it back to the input value, that is 5. So if you plot it on this graph, you will get 2 and 5 somewhat here. So if you now draw the line y is equal to x, you can see that f is a reflection of f inverse, or f inverse is a reflection of f. For example, if you keep a mirror here and this is polished this side and you keep f here, so you will see f inverse as a reflection. Or if you have a mirror polished on this side and you keep f inverse here, so you will see f as a reflection of f inverse. That means these are only one point we have taken in function. For example, if you have a curve like this here, then its reflection is going to be somewhat like this. Okay, if this is your f, this will be your f inverse, or if this is your f, then this will be your f inverse. So f and f inverse are mirror images about the line y is equal to x. Now if function g is the inverse of f, That means f takes f to fx. So g again takes fx back to x. Means we can also write g is equal to f inverse, or we just write g. Okay. So what does this mean? Means this function gx is inverse of fx. That means you have to put the output of fx in gx. What is the output of fx? Fx. You will get x. It will again, take it back to x. So that means g of fx is equal to x. And g of fx is also written as g of x, which we discussed in the last video. Now, if f of g x is equal to g of x, which both are equal to x, that means g of fx is also equal to x, and f of gx, that is also equal to x. Then both these functions g and f are inverse of each other. They are said to be inverse of each other. Now, since we are going to talk about inverse trigonometric functions, let us discuss them. Let us discuss, sine and inverse of sine function. For example, fx is equal to sine x and gx is equal to sine inverse x. Are they inverse of each other? If they are inverse, then f of gx, that will be equal to x, and g of fx, that will also be equal to x. Let's see that. Now, what is g of fx? G of fx is equal to g of fx is sine x, which is equal to, now gx is sine inverse x, sine inverse sine x, right? Now put any value here. For example, g of f, say it is pi by 4. This is equal to sine inverse sine pi by 4, which is equal to sine inverse 1 by root 2, which again is equal to pi by 4. So you can see g of fx is equal to x. Second, let us check f of gx. What is that? Is it also equal to x? So that is f of, now gx is sine inverse x. Now f is sine x, sine of sine inverse x. Now put any value of x here, say g root 3 by 2, which is equal to sine of sine inverse root 3 by 2, which is equal to sine of, now sine inverse root 3 by 2 is pi by 3, and this again is equal to root 3 by 2. So here you can see f of gx is also equal to x. So they are inverse of each other, but we missed one thing. Can you just guess what is the thing which we missed here? Just pause this video and think over it. We have, missed something. I hope some of you must have guessed. See what we have written here. Sine inverse 1 upon root 2 is pi by 4. It's pi by 4. But there are many other angles, infinite angles, whose sine is going to be pi by 4. Pi by 4. I think 3 pi by 4. 9 pi by 4, 11 pi by 4, and so on. Hope I am correct in mentioning. Even if I commit any mistake, you just need to check it. So these are only four examples I have given. There are infinite angles whose sine is 1 upon root 2. But we have only taken one angle, pi by 4. Why? Because we have only taken the values between minus pi by 2 and plus pi by 2. That is the reason. And we generally use the angle between this domain only. Only that is why we have mentioned that, and this is the angle which comes to our mind. And we don't think about all other angles. Similarly, here also sine inverse root 3 by 2 has been mentioned as pi by 3, and there will be again infinite number of angles whose sine will be root 3 by 2. And this is a problem. That means we have some problem in inverse, and we can have inverse only in a particular domain. Let me explain you. For example, you have a function, what we discuss, fx is equal to sine x. You have the domain as x, which will have all real numbers, infinite numbers. If we take some numbers as pi by 4, 3 pi by 4, 9 pi by 4, 11, and so on, there will be many, and you have all elements there. And in fx, that is y, you have again infinite values. I take only one value, say 1 upon root 2, and other values. Now all these values of x, whether it is pi by 4, 3 pi by 4, 9 pi by 4, or 11 pi by 4, they all will be mapped to 1 upon root 2. And these are only four cases which I have depicted here. There will be infinite cases. Now if you want to find the inverse of this function, that is f inverse x, it has to take this value back to where we started. But where is it going to take you back? Whether to this value or this value or this value or this value, and there are infinite cases. So it gets confused. Where so you have to have only one value. So it will take. If you have more than one, then it is not possible for us to have a inverse. Right? I think you got an idea. Again, let me explain you with a sine curve. This is a curve of sine x. Just take a line parallel to x-axis. For this portion itself, it cuts the x-axis, the sine curve at so many points. Now, that means for this value of y, that is sine x, we have so many angles. Say this is theta 1, this is theta 2, this is theta 3, this is your theta 4, this is your theta 5, and this is your theta 6. For all these angles in this small portion of curve, you have so many angles for which the value of sine is same, this one. That means inverse is not possible in this case. Even in this portion of sine curve, forget about the whole sine curve, which comes from minus infinity and goes to plus infinity. You have infinite angles having the same sign. So you can't have inverse in this case. But if I, cut a portion, shaded portion, here the line is cutting only at one point. You don't have more than one angle having the same sign. You don't have it. So you can have inverse in the shaded region. In the shaded region, for every value of x, any value of x, you will have a only one value of y and unique y, and you will have a value for all x. You will have value and a unique value. So this type of mapping is called a bijection. So the inverse function has to be bijective. That means if this is the elements of x and this is y, that is fx, every element in x has to be mapped by one element in y, and there should be no element remaining. So that, which is called bijective mapping. Hope you have studied this. Now, we said that we will be drawing the inverse, or we have the inverse for sine in a particular domain, say minus pi by 2 to plus pi by 2. So you can see if you draw a line parallel to x-axis, it will cut only at one point. So in this region, the curve is a bijection. So the domain is the value of x minus pi by 2 to plus pi by 2. This is the domain, and range is minus 1 to plus 1. So sine x has an inverse from minus pi by 2 to plus pi by 2, and not for the whole, curve. No, it's not possible. You can't have the inverse. You can only have the inverse for certain portion of sine curve. You can take another portion also where you can have inverse, but not for the whole sine curve. Now we take that portion from minus pi by 2 to plus pi by 2. The domain is minus pi by 2 to plus pi by 2, and the range is minus 1 to plus 1. Now we draw the inverse of. Now the domain of inverse will be the range of this function. Domain of sine inverse will be the range of sine curve. That is, this will be the domain and this is going to be the range. Anyway, let's draw the curve. Just see here, you have for value of x as pi by 2, you have y as 1. For 0, you have 0, this one. For minus pi by 2, you have minus 1. Now let's draw the corresponding points in the inverse. I'll mark it with them with red. So for inverse, you will have 1 and pi by 2, because this is going to be the input here, and it will again take it back to the input here. And for 0, you will have 0, and for minus 1, you will have minus pi by 2. Okay. Now let's plot the curve here. For 0, 0, you will have this point. For 1, pi by 2, 1 and pi by 2, and minus 1, minus pi by 2. This one. So the curve will come somewhat like this. So let's draw it. Now, one thing which I discussed just now, that sine curve and its inverse are going to be reflection of each other about the line y is equal to x, or they will be mirror images. So let's